Hi, Robin here. This is a Little Man Computer hack. Little Man Computer is using assembly language, or a simplified version of, and we have our mnemonics, we have our opcode, which is the number at the start of those sort of 3-digit numbers, so the 9 in other words, and the 0. The operand is the second two numbers, so the operand is obviously either an address or data, and then the other two numbers, the 00102, are the instruction address, but also are the program counter. So again, by using that on my computer, what it should really do is give you a good understanding of the way the fetch code execute cycle works within the processor. We have our different mnemonics and their different meanings. I'm not going to spend a long time going through these or anything, because obviously you can pause the video and read these properly at your own leisure. But what we have is common algorithms that can be used within Little Man Computer. And I think what it's a very good idea is to make sure you're familiar with these, because obviously they can come up in an exam, and then if you recognise it straight away, it just puts you at a massive advantage. And also what it does is it gives you confidence that you know how to program these things, and therefore if you get a different situation, perhaps a sort of an unusual algorithm, then you can apply the knowledge you've understood here to understand what's going on. With the different algorithms, I've found over the years that students struggle to read assembly language and Little Man Computer code, mainly because it can go up and down. It can start to get a bit confusion, which I totally understand. So one of the best ways to get your head around this is to use a trace table. A trace table is this table here, and the idea of this is it has a column for each of the things that we need. So this is just a what step are we up to, so kind of what's going on, and that can help us relate to the lines of code that are here. We then have the instructions as well, which obviously matches this code here. We have the accumulator and the value that's going on, and ultimately this one is the most important. That's the one that's going to give us the answer at the end of the day. We then have the program counter. In this case, it's just going 1 to 6, which matches the steps. But if we do have any sort of loops, you'll then see that this changes. And again, that'll help deepen your understanding of the fetch code execute cycle. We then have a variable of first, which relates to this bit at the bottom there. And then we just, in this case, have an output column as well. In many ways, what I would certainly do at first is to overkill this. In other words, write every single one of these columns out. It'll mean that you help get practice at tracking the algorithm and get used to doing it. Once you've done this a few times, you'll find that a few of these columns aren't really needed, particularly the instruction one. You don't need to write that out every single time. It's quite time consuming, and you'll find you can simplify this down as, like I say, you get more and more confident with it. I also have the subtraction algorithm here. Again, you can see in this particular one, there's 2 variables being used, and again, they relate to here. And we can always see those straight away at the bottom because they'll have the DAT mnemonic that goes with them. So again, there's 2 columns, one for the first and one for the second. And you can see that they don't start off with any value, and therefore no value is shown in those columns at first. We again have the accumulator. Like I said, that's the most important one. And then again, we have each of the instructions and the steps drawn out in this particular instance. Okay, so I have a division example here. I'm going to talk about this one in more detail because this is a good example of where students can start to get confused, certainly my experience. And one of the main reasons for that is because of the branches that exist in here. The branches cause the program counter to change quite drastically in some cases, and therefore it causes the program to jump forwards or jump backwards in turn, so that we can create loops and sort of decision points. But that can then cause a confusion. It can cause a difficulty in following what's actually going on in the algorithm. So in this particular instance, you can see at the bottom we've got the 4 variables. I've not bothered to do a column for the 1, just because that is just adding in the value of 1, and it doesn't actually change at all in the algorithm. But the other ones do. Notice the answer has the 0 to start off with, and you can see that replicated up here. The first and the second are empty, so again, are both empty here. We've then got the input is going to be 4, that's our first value, and then the second input will be 2. In other words, we're going to divide 4 by 2. So you can see that the 4 is being input in that first stage, and therefore it goes into the accumulator. We then go to the next step. We can see that the algorithm is starting to move down. and you can see that the value of 4 has moved from the accumulator into the variable place of first because of that instruction there to store first. In other words, we're storing it in the memory location of first. We then take an input for our second value, which, to remember, is 2, and therefore you can see that the accumulator is now changed to 2. We are then, again, told to store it in second, so therefore you can see that now 2 is updated here. We then load the value of first, so in other words, the value of 4 here now goes and replaces the value of 2 in the accumulator. Now we have our first branch decision point. This one particularly is going to ask us, is the value of the accumulator 0? It's not, it's 4. Therefore, in this case, we just move on to the next instruction. And this is a valuable or important property of branches, that if you don't meet the criteria of a branch, the algorithm automatically just moves down to the next instruction. If you do meet the value of that branch, you'll then activate that branch. And this is important because you may have multiple branches, one after another, and therefore the order that they're written in is really important, because whichever is the first criteria to be met will therefore be the one that's activated. We then subtract the memory location of value of second away from 4, which then leaves us with 2 in there. We have store the value in first, so therefore this value here will now replace the value that's currently in the first memory location, so therefore that changes to 2. We then are loading in answer, so therefore the answer value is 0, so therefore that now replaces the accumulator value, so it's now 0. And then we add 1, and if you remember, that add 1 comes from here, and therefore 1 has now gone into the accumulator. We then store that value into the answer, so that's now become 1 in there. And now we've got another branch. In this case, it's a branch always. In other words, if ever this instruction is carried out, it will always take that action. And you can see that what it's going to do is going to use the word loop, and basically what we need to do is look within the code for where there's that loop is repeated, and you can see it's here. In other words, it's going to jump up to there, as you can see has happened now. We now load into the accumulator the value of first, which has gone into there. We then have a branch 0 end. Again, the accumulator isn't 0, so we're going to ignore that. We therefore now subtract the value of second, so the 2 has been taken away, which leaves us with 0. We then store that value in first. We then load the value of answer, 1, into the accumulator. And then we then add 1. So in other words, that 1 has now become 2. We then store that answer into the variable there, as you can see. And then we then have the branch loop decision again. Again, this is branch always, and therefore we're going to go back up to loop again, as happens. We now load first, so we take the value of 0 here, and that becomes the value in the accumulator. And now we meet this criteria of branch 0, because the accumulator is 0. What that means then is we take the end instruction here, and we're going to go down to end here. And that's now happened. So we now load in answer. So we've got 2 has now gone into the accumulator. And therefore we now output 2. Which is correct, isn't it? 4 divided by 2 is 2. The next couple of steps in some regards aren't necessary, but what's actually happening here is it's actually going to clear the accumulators. So in other words, it goes back to 0, and therefore you could start another completely separate algorithm knowing that the accumulator is 0. And this is an important feature to remember, that if we were to leave the 2 in there and start another algorithm, the accumulator would start at 2, and that could then impact on the next algorithm and give us the wrong answer. So in other words, all that's happening here is we're subtracting the value of 2 away to take the accumulator back to 0. Then we store that value, and then we halt. In other words, we stop carrying out the algorithm. I've also given you a remainder, so in other words, a modulus. This is working very similar to a division, except it gives you that remainder value. I've given you a multiplication one to have a look at. And again, you can see in this one, we've got quite a few different data values, hence the different columns that are all up here. I've given you a squaring of a number, so there's sort of 4 by 4 in this case because of our input being 4. Again, make sure you understand that one. I've given you a factorial to have a look at. I've included the sort of what's happening here just because this is a little bit more complicated, just so you can see in this output on there what's going on with that. And I've also given you a Fibonacci because obviously this is a common maths algorithm and therefore could be something you could be expected to recognise or spot. Okay, well, thank you for watching. I hope you found that useful. I really do recommend that you go through each of those algorithms, pausing the video, etc., and trying them out for yourself in a Little Man Computer Simulator. But if you've got anything you're not sure about, please do ask in the comments below. I do want to help you if I possibly can. Okay, best of luck with it. Thank you.